In this video, I will explain perpendicular lines. So if two lines are perpendicular, that means that they meet at an angle of 90 degrees. So if we have that line straight, assuming that line is straight, although in the AB is perpendicular to another line, let's call it this one CD, they are meeting at an angle of 90 degrees. So in terms of gradient and slope, if two lines are perpendicular, then if you multiply their gradients, the answer you get is -1. Assuming the gradient of AB is M1 and the gradient of CD is M2, multiplying M1 and M2, if the two lines are perpendicular, as you can see from this picture, they are actually perpendicular, the multiplication of their gradients will give us -1. So in this example here, we want to compare these lines. We want to assess if they are perpendicular. We have got three lines here, three equations. The first line is y equals to 4x plus 2. We want to compare with line 1 and also line 2. So to start with line 1 is already in the form of y equals to mx plus c. Although it's not really arranged this way, it is arranged differently. C plus mx, gradient. In each case, the coefficient of x with the gradient. So in question A, line 1, the gradient is -1/4, and our reference line, which is 4x plus 2, the gradient is 4. Let's call it the reference line. So we will multiply. Let us designate this one M1 and this one M2. So if we multiply -1/4 times 4, we will get -1. So clearly, line L1 and the reference line y equals to 4x plus 2 are actually perpendicular. So let's try also this one. Now if you look at this one, it's y plus 4x equals to 6. Now this line is not in the form of y equals to mx plus c. So we have to take this 4x to this side. So the new equation of this line will be y equals to minus 4x plus 6. So now the gradient of this line, which is line L2, is -4. L2, the gradient is -4. On the reference line, the gradient is 4. So if we multiply -4 times 4, we get -16. And that's not what you want. So clearly, the reference line and line L2 are not perpendicular. They are not perpendicular.